So JEE Mains from Aldehydes and Ketones, direct question from NCERT. Hydrogen palladium primes of barium sulfate. So this is nothing but Rosenmann's reduction. Ketard CrO2Cl2, Letterman-Koch, Stephen reduction. So easy and direct one. So option 4 will be the correct one. Ketard. When ketard means toluene in presence of CrO2Cl2 will get benzaldehyde. Rosenmann's means benzyl chloride. Palladium in presence of barium sulfate will get benzaldehyde. And Letterman-Koch, benzene plus COHCl anhydrous AlCl3 will get benzaldehyde. And Stephen reaction cyanides with SnCl2 plus HCl will get aldehydes. Simple and direct question. Right, ketard reaction when toluene with CrO2Cl2 will get benzaldehyde. So nothing but what? This is ketard reaction. Rosenmann's reaction, benzyl chloride, reduction with palladium, barium sulfate will get benzaldehyde. Next, Letterman-Koch reaction, benzene when treated with carbon monoxide, CO plus HCl in presence of anhydrous AlCl3, here also will get benzaldehyde. And Stephen reaction, generally cyanides when treated with SnCl2 in presence of HCl, after hydrolysis will get aldehydes. So one of the easy and direct question from aldehydes and ketones. One more question from aldehydes and ketones. An organic compound P molecular formula C6H12O3 gives positive iodoform test but negative tolerance test. When P is treated with dilute acid Q gives the positive tolerance test and also iodoform test. Structure of P they are asking. So in this case, particularly we need to understand that what is iodoform test, which type of compounds will give the iodoform test and tolerance test. So simply try to understand methyl ketones. Whenever the methyl ketones are there, these will give the iodoform test. Means aldehydes and ketones which are having CH3C double bond O group and CH3 CHOH. These compounds also will give the positive haloform test or iodoform test. And generally aldehydes will give the tolerance test but not ketones. The tolerance test to identify aldehydes from ketones. Aldehydes will give the tolerance test but not ketones. And in this case hydrolysis of ethers is important. So when ethers when CH3 C whatever the, for example OCH3 when we are doing the hydrolysis of ethers, so simply we need to break the bond. Just put OH like this, OH minus H plus like OH H. Nothing but here is CH3 CH OH OH. We know carbon contains only one OH group is stable. So in these two cases, two OH groups are there. One water molecule is going out. CH3 C double bond OH. Aldehydes like this will get the aldehydes. In this case, particularly if we will take the, I'm just going with the option 2, CH3C double bond O group. This gives the positive iodoform test. So an organic compound molecular formula gives a positive iodoform test. Is it fine? This first one is also will give. Second one, this won't give because this is having the aldehyde group. So this also can give. So according to POE, process of elimination, we can remove the third option first. So option 1, 2 and 4 might be the answers. And after here is OH and OH is coming, so it also gives the CH3 C double bond O COH CH and CH2OH. all 2 holes, this probably it gives the, of course, it gives the positive iodoform test, but after it won't give the tolerance test, no tolerance test. So according to POE, option A1 also wrong. And here I already told you this one, CH3 C double bond O, so then OH, no? After doing the hydrolysis OH, CH3, this will converting into CH3 C double bond O, C double bond O, CH3. This also won't give tolerance test, because here is we will get the ketone over here. So the answer will be second one, CH3 C double bond O, OO. So we'll get the compound is CH3 C double bond O, CH2 C double bond O, H. This gives the positive tolerance test. Positive tolerance test. This gives positive iodoform test. One of the important reaction and combination. Here is they are asking aldehydes, ketones in the 2 iodoform test, tolerance test, along with hydrolysis of ethers also we need to know. So whenever we are doing the hydrolysis of ethers, so we should know this process, right? OCH3, like whenever the OCH3 is given, so OH we need to add. Okay, this is the answer will be second one is the answer. So one more question. This is iodoform test. Once again, they ask the iodoform test. They keep on asking the iodoform test questions. I told you CH3 C double bond O groups, aldehydes and ketones which are having methyl ketone will give the iodoform test, and all 2 holes means at second position if the OH group is there, that also gives the positive haloform test or iodoform test, because upon oxygen, iodine acts as an oxidizing agent, will get this compound. Along with this, one more CH3CH2 OH, ethanol also will give the positive iodoform test. These 3 just keep in your mind. So now we'll cross check the options. So iodoform test differentiate between methanol and ethanol. So methanol and ethanol, CH3OH and ethanol. So this won't give, this gives. Of course we can differentiate. A will be, we can differentiate, right? Acetic acid and propanoic acid, obviously it won't. We can't differentiate because it won't, iodoform test won't give by the acids. Cyclohexene and cyclohexanone, it won't give. And diethyl ether and pentane 3-one. So diethyl ether CH3CH2 OCH2CH3, pentane 1 2 3 4 5, pentane 3-one, all 2 ones will. So this is also wrong, it won't give. And anisole and acetone, anisole means methoxybenzene, it won't give. And acetone will give the positive iodoform test. Acetone will give the positive iodoform test. A and E, option A will be the right answer.